the Organic Science Cluster program is led by the Organic Federation of Canada as the industry applicant, and we work together with the Federation to develop this program on behalf of the researchers and in collaboration with the researchers across the country. So the Organic Science Cluster program is, we're on our second cluster, and it is a national program that's funded by Agriculture and Agri-Food Canada through their Agri-Innovation program. And it's a 5-year research program that we pretty much set all of the research priorities and the projects at the beginning of the 5 years, and then it allows continuity for the projects to continue over that time frame. The total value of the Science Cluster 2 program is $10.5 million or thereabouts. There's a cost-sharing ratio that's involved, so about 75% of the funding comes from the federal government, and about 25% comes from industry. And so therefore, we're looking at industry contribution of over $2 million towards this science program. So all told, this is the Science Cluster makes up one of the largest federal government contributions to organic agriculture in the country. And so we want to make sure that we gratefully acknowledge that contribution. And the Science Cluster program is, if you go to our website that hosts the Science Cluster, it's dal.ca/OACC, and if you click on the Clusters tab, or Science Clusters tab, you'll see all the information about the Science Clusters and the latest results from all of the different projects. This cluster has 37 different research activities or different research projects happening right across the country. It involves university scientists as well as Agriculture and Agri-Food Canada scientists. And many of the projects are happening right on farms. The projects are funded by industry partners that may range from individual farmers to large businesses or commodity groups. And all of that information is available on our website. We also just recently presented a magazine that provides, or produced a magazine that provides an overview, a brief snapshot of each of the research activities, and I believe that link was included when the announcement went out regarding these sessions. So with that, we have two sessions that will be held today and on, I think, April 11th, if I remember correctly. And today we have 3 presenters, and most of them are quite well known, or I think they're all very well known already in the prairies. And so I won't spend too much time with introductions. Rather, I'll allow more time for questions. The first presentation is from Dr. Myriam Fernandez, who's with Agriculture and Agri-Food Canada in Swift Current, and she will be speaking on reduced tillage work on prairie soils. So I actually didn't hear if Myriam has signed on, so
yes, I'm here.
Great. So Myriam, you have 15 minutes, and then we'll have a few minutes for questions after. So fire away.
Thanks a lot, Andy, and thanks to Iris as well. Good morning, all. Most of the research on the impacts of changing organic management practices in Western Canada has been done in the dark brown or black soil zones where weather and soil conditions are more favorable for crop production than in the brown soils. So we conducted a field study here in the brown soil to determine if organic wheat production systems involving diversified crop rotations and reduced tillage could optimize production while minimizing its environmental impact. So the trial that I'm going to be talking about today was run from 2010 to 2015 and had 2 tillage treatments, high and low, and there's a little bit of a description in the handout, but I could elaborate later, and 2 rotation treatments, a simplified rotation with wheat alternated with green manure, and a diversified 4-year rotation with wheat followed by an oilseed crop, a pulse crop, and green manure. So I'm just going to be presenting an overall very brief summary of our results and our final report and publications on this study built separately with soil and crop parameters. So if anybody's interested in this comprehensive report, just let me know. They will be available very soon. So for this presentation, I'll be referring mostly to wheat. And before I start, I should mention that the precipitation totals for the growing season was above average for the whole study period and ranged from very wet in 2010, being 170% of the long-term mean, to very dry in 2015, being 65% of the long-term mean. And this was actually the only dry year that we had in the whole trial. So starting with soil parameters, we found that soil nitrate and phosphorus content in the spring were highest in the first years of the trial, and then both went down in the last few years. Soil nitrate levels in the plots to be seeded to wheat were significantly higher under high than low tillage in the simplified rotation, and were also significantly higher in the simplified and diversified rotation under high tillage. In contrast, organic carbon tended to be higher in the diversified and the simplified rotation, and also tended to be higher under low tillage than high tillage, increasing in the low tillage over time. In addition, the percentage of small soil aggregates was lower in the low tillage than the high tillage in the diversified rotation, and wet soil aggregate stability was also greater under low tillage. So these differences in soil aggregates mean that an increase in the soil resistance to wind and water erosion would be expected in the low tillage treatment. So switching to crop parameters, we found that grain yield was highest at the beginning of the trial in the first couple of years, and then decreased more or less steadily over the following years. And regardless of crop rotation, wheat yields were significantly higher in the high tillage, and while regardless of tillage method, the wheat yields in the simplified rotation were higher than in diversified rotation. And this resulted in the high tillage simplified rotation combination having the highest and most stable yields throughout. And actually, you can see this data in the handout. It's the only table in that document. So despite the lower spring soil nitrate levels under low and high tillage, wheat grain protein concentration was mostly similar among treatments. So differences in the impacts of the various treatments on yield and protein concentration suggest that there are no negative association between them, in contrast to what is commonly observed in conventional systems, typically receiving synthetic fertilizers. So this might be explained by the release of mineralized nitrogen throughout the season in organic systems from a previous green manure or pulse crop. So how do yield and protein in our organic trial compare to those of conventional wheat? We compared our grain yields and protein concentration to those of the same cultivar in a nearby conventional trial, and also to commercial crops in the area, most of which were assumed to be conventional, and the data was provided by Crop Insurance and the Canadian Grain Commission. So a comparison of yields in the organic trial with those in similar cropping sequences in the nearby conventional trial showed higher yields of the organic wheat in the first year of the trial, but because of the subsequent lower performance in our organic trial, over the full study period, the organic wheat yielded an average of 75% of the conventional wheat. And compared to commercial crops, over all years, organic yields were an average of 85% of the commercial crops. And again, yields in our organic trial were higher than in the commercial crops at the beginning by an average of about 30%, and then declined down to being only about 61% of the commercial wheat in the final year of our trial. In regards to protein, overall organic wheat protein concentration was similar to that in the wheat in the nearby conventional trial, with protein values in the organic over the conventional wheat ranging from an average of about 109% in the first 3 years to an average of 91% in the last 2 years of our trial. So organic wheat appeared to have a clear advantage over conventional wheat in regards to protein levels, except for the last 2 years of the trial. So in regards to wheats, we found that wheat biomass was significantly lower and high than low tillage in some, but not all years. But there was a steady increase in the density of perennial thistles, especially under low tillage throughout the study period, and this was particularly so from 2013 onwards. So according to our data, total wheat biomass appeared to have been affected more by environmental conditions and the competitiveness of the crops, while the density of perennial wheats, once they were well established, appeared to be affected more by tillage practice than by environment. So we also conducted the regressions among the various parameters, and this showed that wheat yield variation was explained more by precipitation and soil nitrate levels in the spring than by weed infestations. And this is actually similar to what others have reported, including here in Saskatchewan. So we conclude that growing wheat organically alternated with green manure, although resulting in higher nitrogen availability and acceptable yields in the short term, might not be enough to maintain productivity in the longer term, given the apparent depletion of nitrogen over time. Our results also showed that more diversified rotations with green manure every 4 years would be even more inefficient at achieving wheat yields comparable to conventional production. On the other hand, the low tillage and diversified rotation treatments appear to promote enhanced soil organic carbon and also resulted in an apparent increase in the percentage of large soil aggregate fractions, contributing to the environmental sustainability of organic crop production. So on this basis, we can conclude that a different strategy for increasing soil nitrate would be needed in organic systems without compromising soil quality. So based on the results obtained in years with above average precipitation, which were most of the years in which we conducted this trial, especially the steady increase in the density of perennial thistles, the low tillage treatment would not appear to be viable for more than a few years. However, it's also true that more typical environmental conditions for this area may result in a different outcome, although at this point we don't know what the more typical environmental conditions in our area are anymore. So we suggest that strategic tillage involving the occasional use of more intensive and frequent tillage could help mitigate the potential adverse effects of perennial weeds when their levels become unmanageable with less soil disturbance methods, in addition to also contributing to increased nitrogen mineralization, and they could also have other advantages in regards to disease control. So in synthesis, it appears that flexibility remains necessary in organic cropping systems using reduced tillage when perennial weeds need to be better controlled to minimize their effect on crop growth. And I think I'm going to stop here. If there are any questions, I'll be happy to answer them.
Thank you, Myriam. A very nice overview. And we're going to take just a few minutes for questions for Myriam. So if you don't have a question, I remind you to keep your lines mute. Everything's been great so far, but if you have a question, feel free to ask now.
Oh, Andy, I should also mention, sorry, I forgot that the acknowledgments for the funding and also for the in-kind contributions to our project were stated in the document, as well as the co-authors of this work.
Great. Thank you, Myriam. So, Myriam, had you done any economic analysis on the rotations to see not just the yield performance, but also the economic performance of the systems?
Yeah, that's next, actually. We are trying to, we're in the process of getting the first two manuscripts out. One is on the soil parameters, and the other one is on the crops, and then there will be other papers, including one on diseases, and of course one on an economic analysis, and we'll probably also do carbon footprint analysis. So we are in the process of finding someone to do this work, because Bob Fenner, as you know, has retired, and he was going to do this analysis. So maybe in a year I will have some data about, I'll have some results on the economic analysis at least. Yeah.
Great. Are there any other questions for Myriam at this point? We will probably have a little bit of time for some more discussion at the end.
I had a quick question.
Yep, go ahead.
Michael Thiele here. Hi, Myriam. Thanks for your research and presentation. It's just more me trying to understand exactly what your research is all about here. So the soils that you conducted the research on, was this plot work, or was this conducted over a number of farms, sort of typically farmed land over the past 100 years, typical prairie ag soils now?
Yeah, thanks for the question. This trial was at our research center, and it wasn't conducted on any farms. It was just at our center.
Right. So those soils would have been used for plot work now for several decades.
Oh yeah, but I mean, I should probably. You see, I didn't have time to explain everything in detail, but this is going to be explained in the final report. But it was conventional for many years, and then we had the green manure for a couple of years, and 4-HP green manure, and then we started this trial in 2010.
Right.
So it was the third year that was run organically.
Right. The reason I ask is it seems that a lot of what we say in agriculture now, and this is just, again, me trying to understand some of these new ideas that are emerging in ag and more related to soil biology and all this, is that we almost have to preface a lot of our research or what we do in ag with, the statement, on a degraded soil, this is what we found. But it appears, and this is sort of work I'm doing with producers, in the real world, is once we start turning these soils around and they're no longer low carbon and shut down biology and low infiltration, all these issues that are kind of typical now to the soils we're farming on the prairies. Once you change all these things, it's like the rules of the game are completely changed.
Right.
So we're having fairly good success with and hoping to move more towards a low-till, diversified organic rotation, and hope that we can make that work. And it would, anyways, that's just a few comments that I think once we turn around a degraded soil, some of the rules of the game are completely different, and in a positive way. So.
Yeah. No, I mean, thanks for your comment. We started our organic research program in 2007, so this was all we were able to get, and we are encouraging on-farm research projects, but we will not be able to do them ourselves for, practical matters such as, moving equipment and that kind of thing. And I should also mention that one of the papers that is also going to come out is by Newton Lupoye on the microbial communities in this trial over time. And the other analysis that we did and that is included in the paper on soil is we looked at nitrogen and phosphorus in the soil profile down to 120 centimeters, and the results were very interesting. And it kind of indicates, for example, in the case of phosphorus, that the decline in the phosphorus over time occurred mostly in the upper 0 to 15 centimeters over time, but because the roots of most of the crops will be under 15 centimeters, there was an indication that would not affect the crops over time. So so that was quite interesting. It was a different story with nitrogen, of course. But in terms of phosphorus, which is something of great interest to organic producers, that is what we found.
Okay, so we have about 10 to 15 minutes that we can offer for general comments, discussion, or questions. And if Jennifer and Myriam, are you still both on the line?
Yes.
Great.
Yes.
So we'll open it up to questions or discussion on all three present.
Will Odie here. Going back to the discussion about oats versus wheat breeding under an organic regime, I think, there certainly was an advantage in the oat scenario to have grain millers as a corporate entity pushed behind this and obviously registering the crop or licensing it. And of course, the thing is that the problem that exists at the milling end is whether a crop produces better or has better yield. It doesn't really affect the millers at all, as long as they're getting the product they want. So really it's up to the farmers to push forward and make their voices known that, in fact, they want organic regime breeding trials for wheat as well. And I think, as I mentioned, that research that came out of the University of Manitoba, 10% is a pretty striking difference. What was interesting, I think, if my reading of that research was correct, was that actually the yields on the organically researched crops were actually better under conventional regimes after the crop got to that point, as well as under organic.
That's true. AAC tradition does yield very well across environments. And that was the cultivar that was developed organically.
It's Martin Entz here. I just wanted to, support what Will said. We actually published, that work was Ann Kirk's master's, and it was published in 2012, and it showed it showed that 10% yield increase and higher protein and larger, plumper kernels, so that breeding under organic really did make a difference. And that was a very good study, because it was the same population selected under both systems. But in terms of the other partner that we need is a willing plant breeder, and it just so happened that when that work was finished, the Ag Canada plant breeder left for another job, and so we lost that breeding leader. And I just want to, shout out to the Ag Canada colleagues who we've heard from today, that their dedication to doing something in organic has been really critical, because when you get somebody who's a wheat breeder in Western Canada, applying for funds from industry for organic wheat breeding, they're not going to have trouble getting the funds. We just really need that leadership, and so we've been working with the wheat breeders in Ag Canada, but we're hoping that we have an enthusiastic one come forward. So those are my thoughts.
Very well put, Martin. It's exactly the issue that we have right now. And we need the farmers to be approaching and talking with the wheat breeders and bringing them into the fold. So by the time we get to our next science cluster program in 5 years, that they are primed and ready to go. Further questions for the speakers?
Yeah, Scott Beaton calling from West Winnipeg. I just had a quick one for Dr. Mitchell-Fetch. The availability of those oat cultivars that you've been working on, how does it look for the next few years?
I believe AAC or Avena will be, there will be some seed available this spring. OT 8006 or AAC Consor will just start into the pedigreed system this spring, so it will be 2 or 3 years before there's any certified seed available.
Okay, and it's available through whom, or did Stuart buy it all up for this year?
Stuart didn't get it all. It's Scott here with Grain Millers. I was just going to make the comment that we tasked Fedoric Seeds at CAMSAC with doing the multiplication and basically handling the seed sales for us. We're not an input company or don't want to pretend to be one, so we hired some real good professionals to do that. I'll give you their number for any of the producers that are on that want to inquire further about it. They're 306-542-4235. I believe there still is seed available. I'm not sure on the amount or cost or anything like that, but Mike or Rod at Fedoric Seeds can help you with that.
Perfect. Thanks, guys.
Will Odie speaking. I did make an inquiry back in February, and they weren't quite organized at that point. They didn't have any clean, but the price was going to be, I think, around $11.50 a bushel from Fedoric's.
Oh, and I guess one other note on the seed thing. So with buying the seed, you are not required, even though we have the license on it, you aren't required to sell it, your grain back to grain millers. It is an open variety for you to grow and market how you please. But we would love you to sell it back to us, of course.
Any other questions from the group?
Yeah, I think there's a real vote of thanks should be given to grain millers for pushing this forward. It's it may be the first of many varieties over the years, but it's a great start. So thank you to grain millers.
And I wanted to take a moment to acknowledge all of the industry partners that were contributing to these particular research projects. So it was grain millers and Cliff Bar and Prairie Oat Growers Association, and then Western Grains Research Foundation on Myriam's project, and then on Steve's we had Sask Pulse, as well as Western Grains Research Foundation. So it's really important that we stay connected, especially to these. It's really nice to see the commodity groups contributing to organic research as well, and so I think if we can get more organic growers sitting on boards of some of these commodity groups and showing that there's a real market and some integrity in the organic side, that builds further industry support also. So thank you very much. Any other questions before we close down? I do have one for Jennifer that's I've always kind of been been wondering, I guess, is to what extent, like, genomics is not genetic engineering. Genomics is looking at the genome of the oats in this case and mapping it and understanding what genes are turned on or off or suppressed and so on. And do you use genomics when you're doing your breeding program for oats?
I do use the genomics, or at least a subsection of it called molecular marker-assisted breeding in the conventional program, and we've just started using it more regularly in the last couple of years because we've finally gotten some markers available or identified that are really useful in my program, and I'm starting to get very excited about the possibilities of where we can go with using marker-assisted breeding and marker-assisted back crossing, which is another tactic that we use. And I'm hoping with the next Growing Forward or Organic Science Cluster number 3 that we will be able to incorporate molecular markers into the organic program as well. And I think there's a lot of things that we can't identify just by looking at the lines in the field, but perhaps with molecular markers we can identify those traits and make sure we keep them in the program and have them in the finished cultivars. So I'm getting excited about this part of the program.
Great. Thank you very much, Jennifer. I'm excited to hear that. I do get questions whenever I get into breeding discussions with anyone from locally or around the world. They do come back and ask if marker-assisted breeding is being used in Canada for organic breeding programs. So very good. Any other last questions?